What is scientific notation? So we're going to talk about that. We're going to talk about going from numbers to scientific notation and also from scientific notation to numbers. And then we're going to end by multiplying and dividing using scientific notation, which is kind of just a continuation of all the exponent stuff that we've already been doing. So what is scientific notation? So basically, at some point in the world, scientists got together and said, hey, we're using these really, really big numbers and we're using these really, really small numbers. And instead of me saying, well, this case is kind of different, it's only 93 million, but I mean, it could be 93 trillion or 93 billion. Like, you don't want to say all that. So they came up with this notation that you can use. And it's used mainly in math and science, which side note, that's why we did this lesson. Normally I skip scientific notation, but there's a couple of the science professors that asked me to cover it because you will be using it in your science classes, biology, chemistry, all that fun stuff. So anyways, that's what scientific notation is. It's being able to take large numbers and making them semi-small, or the way that we talk about them, semi-small, and the same thing with small numbers and making those in a way that we can talk about it. Because even that number there, that's talking about blue light, like you have blue light glasses, that's 475. I don't even know what place value that is, but it's a really, really small number. So scientific notation, what is the key here? So this is kind of what we're talking about. Let me grab my pen here real quick. Sorry. So scientific notation looks like some number times 10 raised to the exponent. So one thing that I talked about in class was this idea. We talked about in class on Friday what anything to the 0 power is, and I think we said that that's going to be 1. So 10 to the first is going to be 10, 10 to the second is 100, and 10 to the third is 1,000. So basically, as you can see, as our exponent gets higher, we're multiplying by a larger and larger number. So same thing with scientific notation. As we get if we have a positive exponent, our number is really going to be really, really big, which is going to be written in a condensed form, I guess is the best way to say it. And then remember, just a review from Friday, 10 to the negative 1 goes to the magic fraction bar. That's 1 over 10, and that's 1 over 100. If you guys weren't here, you can write that over 1. It crosses what I call the magic fraction bar. When it does that, the exponent becomes positive. So the other key with this one is really right here. Recognizing that your A value is the absolute value. Remember, that means that's both positive and negative numbers. But it has to fall between 1 and 10. Okay? So a game that we played in class today, one of my favorites is where is the decimal point? And the reason why I did this is because I honestly think this is probably the most biggest struggle for students when it comes to scientific notation. So here, obviously here's the decimal point, right? So one thing that I ask students is, what is the name of this place value right here? So I don't know if you guys remember, but I would say this is 41.5. So the 1 in this case is going to be my ones place. And I don't know if you guys remember your place value, but the 5 here is what we call the tenths. So a decimal point will always fall between our ones and our tenths. So for instance, in this one, well, technically there's a 0 right there in our ones place and a 0 in our tens place, so that falls there. Now, this is the hard one. This is a great question. So a lot of people struggle with this one. If I asked you, I was just working with a student tonight, and I said, where's the decimal point? And they didn't know. And it is kind of hard, but you have to recognize that your decimal point, because that is 4. That's just the number 4, right? So I would say in the number 4, there are 4 ones. So that means that I technically have a decimal point that's right there. Same thing with this one, 415. I would say that I have a decimal point that's right there. Okay? So anyways, I know it's weird, but if you're not given a decimal point, it's going to be at the end of the numbers, especially when we're talking about large numbers. Okay? So for instance, it says write in scientific notation. Okay? So remember, that's A times 10 to some exponent, right? Our A has to be between 1 and 10, and it can't be 10. Okay? So it has to be less than that. So I'm going to make my A 5.71. Because my question is that between 1 and 10? It sure is, right? I couldn't make it 57.1 because that's bigger than 10. I couldn't make it 571 because that's way bigger than 10. So it's 5.71. Now here's how I do it. I think about a number line, okay? So if here's 0, as I move to the right on a number line, I would say that those are going to be positive. And as I move to the left on the number line, those are going to be negative. So I always start, so this is times 10. I always start with my, so whatever my decimal is, and I want to get back to the original. So I'm going to have to move this 1, and I'm going to have to move that 2. So because I went to the left, that's going to be a negative 2. So this is my final answer when it comes to scientific notation. So it's 5.71 times 10 to the negative 2. Okay? So take a look, take a second, look at that. Like I said, A is going to be between 1 and 10. I did that by making it 5.71. I put my decimal point that I had to do was right there. So to get it back to the original one, I'd have to move 2 to the left, which is why this is a negative 2. Okay? So go ahead and pause the video and try these out. Okay, so for the first one, I think it's going to be 4.23 times 10. Remember, here's where my decimal is, right? Because it's 4.23 is between 1 and 10. I only had to move it 1 to the left, so that's going to be minus 1. This one's going to be 8.71 times 10. Again, here's my decimal point. I had to move it 1, 2, 3, so that's going to be negative 3 right there. And then 9, be careful. So just 9 times 10, here's this, times the negative 2. Okay, so again, you go from yours to the original. Yours to original. Okay, so for instance, now we have this one. Now this is where, I know that was a cheesy game we played at the beginning, but this is a great question. Where is the decimal point? The decimal point is right there. So again, I have to make my number between 1 and 10, so I'm going to make it 2.14. Now I have to go from here, 1, 2, 3, 4, 5, 6, 7, 8, 9, times 10 to the positive 9. Now it's 10 to the positive 9 because this is the one that I put right here. This is the original, even though I wrote it in red. It's not there, but that's where it is. I'm moving to the right, so it's going to be a positive 9. So go ahead and pause the video and try these. Okay, so again, original is here, right? 9.3 times 10. 1, 2, 3 to the third power. Original is there. Now this one's kind of tricky. One thing that I didn't really say is I have to do 1 point because that's between 1 and 10. But you have to include all the zeros between all the other whole numbers. So in this case, my A is 1.0409. I don't include these 3. I just include the ones that are between my 1 and the other whole numbers. So in this case, the 4 is a whole number and 9 is a whole number. Times 10, so again, I'm here. So I have to go 1, 2, 3, 4, 5, 6, 7. And then finally, this is a weird one. You'd never do this, but actual decimal point is there. I'm putting mine there, so that'd be 9.8 times 10 to the first. Kind of weird, so hopefully those made a little bit of sense. All right, now, what if we're given scientific notation and we're asked to put it into standard notation, as they call it? So here, I have 3.204 times 10 to the fourth. To me, that's a positive 4. So here's what I do. I make baskets. I think of Easter. There's 1 basket, there's 2 basket, there's 3 baskets, there's 4 basket. This is where my decimal ends up. Every basket that is empty gets an egg or a 0. So in this case, this number is really 32,040. Right? So this one, 3.204. 4 to the left. 1 basket, 2 basket, 3 basket, 4 basket. 0, 0, 0. So that's my final answer. So I know it's weird. It's just the way I think about it. Easter, I make baskets. Every time there's a basket, I put an egg in it, aka a 0, and that's going to give me my scientific notation. Okay? Go ahead and take a second and do this one. Now on C, there's a negative. Don't worry, just put a negative in front. Okay, this one's kind of nice. We're going to move the decimal 5 places to the right, right? Because there's, it's a positive, so it should be 870,000. So again, I moved it 1 to get on this side of the 7, and then I should have 4 more zeros. This one, just going the other way, make my basket. I should have 5 eggs or 5 zeros. And then finally, I should have 3 eggs or 3 zeros. Okay? All right, last step. multiply. So this says write both in scientific notation and standard notation. Okay, here's how I do this one. Bring your whole numbers together. Bring your powers of 10 together. What's 2 times 4? 8. Now, last chapter, like bases, product rule. What do we do with the exponents? We add them. So this is my scientific notation. And an 8 with 8 zeros is going to be, I did 9, sorry. 8 zeros is going to be my, that's a terrible number. Sorry, it should be 800 million. I'm sorry. That's a comma. So hopefully it made sense. So basically, you take your whole numbers, multiply together, take your exponents, multiply together. So go ahead and take a minute, try this one. Now, I'm going to guess where some of you guys went wrong. Is you got to that, perfect. You got to that. Now the question is that in scientific notation? The answer is no. Because remember, scientific notation has to be between 1 and 10. So my decimal points here, I really need it to be there. So that's going to be 1.5 times 10 to the 4. So just be careful on those. I know that's a little confusing, but again, this gave me 15. 3 times 5 is 15. But I need it to be 1.5. So I'm going to have to add an additional place that I have to go for the place value. This one, I'm just going to jump straight to this one. Again, separate them. 4.8 divided by 2.4 is 2. When I divide, remember when I multiply like bases, I add. So when I divide, I subtract. So this one, I'm going to move 1, 2, 3, and I think I'm going to get